Lesson 3.5, using the distributive property to solve equations. Learning target today, we should be able to solve some more complex equations by first simplifying. There isn't a whole lot different in Lesson 3.5 than there was in Lesson 3.4, so you won't hear a whole lot of my voice, but I plan to talk you through as much as need be. So, let's go ahead, warm up. Should be able to solve each of these equations fairly quickly at this point. Take a moment, press pause, and then continue. Hopefully you came up with the same values that you see here. Sometimes equations are solved simply in our heads. Other times we need to simplify the equations down to make them a little bit more simple to solve. Part of the simplifying process may require combining like terms or distributing some multiplication into parentheses, similar to what we did in Chapter 2. Let's take a look. Here we're going to use the distributive property to solve equations by combining like terms. Sometimes a situation or equation may have more than one part that involves the variable. 3 examples where you might see this. Please take a moment to read each of them. As always, you don't have to write down all the words of the examples, but it is important to follow along. After reading this example, we can take a look at setting up an equation to help us solve, that we can solve to help us answer the question. In this case, we might let C be equal to the amount each child receives, which is what the question is asking us. Then we would see the total estate being equal to 4C for the 4 children, plus 6 times 1/2 C, 6 for each of 6 grandchildren, each receiving half of the child's share, plus $35,000 to the charity. You might see an example that's just a straightforward equation, or you might see an example that involves a shape, like the triangle that you see here. If the perimeter of the triangle is 50, what is the value of h? We might use an equation that adds each of the sides to h, plus the h plus 7 side, plus the 21 plus negative h side. We're going to see how to work through each of these examples. Please choose 2 of them to copy down in your notes. To use the distributive property, we will first begin by combining like terms to create an equivalent, more simple equation that can be easily solved. Ooh, what's missing here? Our first example, we were able to set up an equation to represent the situation. The first step might be to simplify this term. 6 times 0.5 times c would give us 3c. Of course, with our train tracks, we want to take a look at the left side and the right side separately. Combining like terms, we arrive here at 7c. 4c plus 3c is 7c. The 35,000 does not combine because it is a constant term. Therefore, it will not combine with the 7c. As we go ahead and take a look, our next job, just like in lesson 3.4, is to add the opposite of the constant. So we're adding negative 35,000 to both sides. The result on the left side becomes 315,000, and on the right side is 7c. Our last step is to divide by the coefficient, finding out that 45,000 is equal to c, so each child gets 45,000. When we check this, we want to make sure it fits with the original situation. So does it fit the situation? 4 children get $45,000 apiece. That gives a total of $180,000. This would mean that 6 grandchildren get $22,500 apiece for a total of $135,000. The charity, of course, gets $35,000. If we find the total of each of these 3 parts, we can see that it adds up to the total estate of $350,000. Our next example, we were asked to take a look at a straightforward equation. Our first step in this instance might be to combine like terms here. Our like terms being the 12y plus y, arriving at 13y. We can add the opposite of the constant, our constant being -1, so we will add +1 to both sides. This results in the equivalent equation 13y equals 78. After combining like terms, we want to divide by our coefficient, so we can see our common factor of 13 times in both the numerator and denominator, and our common factor of 13 times in the numerator and denominator on the right side. Our simplification results in y equals 6. Does this fit the original equation? We'll go ahead back to the original equation. Wherever I saw a y, I'll replace it with a 6. Following order of operations, starting of course with the multiplication, addition, and finally subtraction. It does fit in the original equation. Our next example, we were asked to find if the perimeter of the triangle is 50, what is the value of h? We began by writing an equation with each of the three sides, 2h plus the h plus 7 side plus the 21 plus -h side, making it equal to 50. First thing that we would want to do is to combine our like terms, resulting in the equation 2h plus 28 equals 50. Next, of course, we want to add the opposite of the constant to both sides. Here, our constant is 28, so we will add -28 to both sides. Next, we would want to go ahead and combine our like terms, which we can see 28 and -28 combine, as well as 50 and -28. Next, we would want to divide both sides by the coefficient. The coefficient being 2, look for our common factors. Common factors being a 2 times and a 2 times, as well as a 2 times and a 2 times. We find out that h equals 11. So after we've simplified the 2 times and the 2 times, leaving our 1s, we can simplify the 2 times on this side, leaving an 11 numerator and a 1 denominator. We came up with h equals 11. It always makes sense to go back and check it. If I substitute h here, I have a side of 22, a side of 18, and a side of 10. If I add each of those sides together, we do find the result of the perimeter 50. Sometimes we need to use the distributive property to make an equation simpler by distributing the multiplication. An example of this could be a yoga studio charges a $50 registration fee, which includes the first 2 classes. Each additional class will cost $15. How many classes can you take for $140? We're going to need to define a variable here. For example, C is the total number of classes. Then we can say $140, the total cost, is equal to, it's made up of the $50 registration plus the $15 for every class except the first 2. So instead of just doing 15 times C, we're doing 15 times C minus 2. So we can see that this is just the classes after the first 2. Another example, we might be asked to solve a straightforward equation, or we may be asked to consider the perimeter, or excuse me, the area of a rectangle. Here we know that the area of the rectangle is 108 centimeters squared. What is the value of n? We could set up an equation where we are multiplying 5, the height of the rectangle, times the width or the base of the rectangle, which is made up of the side length of 3, as well as the side length of 2n minus 6. You'll see each of these examples worked through. You only have to do one of them. Wait, that says 2. You should work through 2 of these examples. So let's get started with our yoga studio. If necessary, we will begin by distributing the multiplication to make an equation that is equivalent but easier to solve. So, our equation with our yoga studio. Can we use the distributive property to eliminate the parentheses, making this an easier equation to solve? We can do that by distributing 15 times into the parentheses. So we can see 15 times the first term of the parentheses, C, and 15 times the second term of the parentheses, the -2. If we simplify all terms in our equation, we find out that 150 equals 50 plus 15c plus negative 30. If we combine our like terms on each side, we find out that 140 is equal to 20 plus 15c. From here, this is a fairly basic equation. We've got our constant term here of 20. We want to eliminate it by adding the opposite to both sides. So we can see negative 20 being added on both sides. Combine the terms on each side, resulting in 120 equals 15c. Next thing that we would want to do is divide by our coefficient of 15. If we divide by our coefficient of 15, we can see a common factor of 15 simplifying out on the right side. On the left side, it looks like we also have a common factor of 15, leaving behind a 1. And an 8. If we simplify those common factors, we find out that 8 equals c. If we go back to the beginning, c represented the total number of classes that we can take for a total charge of $140. It's always a good idea to check to see if this fits in the original situation. So if I check, I would have my registration fee of $50. And then I would pay $15 for each of the classes except for the first two. So that means I am taking 6 times 15. I did not pay the $15 for the first two classes. And if I multiply 6 times 15, the result is 90. Therefore, I can see my $140. Next example might just be a straightforward equation. We would begin solving this equation by, of course, changing minus to plus negatives. We need to distribute the 3 times into the first parentheses and the negative into the second parentheses, resulting in 3 times 4m plus 3 times 3 plus the opposite of 14m plus positive 11 equals 8. Simplify each term. Combine like terms. Now we have a fairly simple equation. Add the opposite of the constant. Both sides. Combine like terms. Divide both sides by the coefficient, resulting in m equals 6. Of course, we always want to check our answer. Fun fact about the check on this one. Go ahead and take a moment to read it. And our last example. We know the area of the rectangle, largest rectangle, should be 108 centimeters squared. So earlier we set up an equation that could be solved. We would begin by distributing the 5 times into the parentheses. We can see 5 times each term of the parentheses. Simplifying each of those terms, the result is 15 plus 10n plus negative 30. If we combine our like terms, we see negative 15 plus 10n equals 108. If we add the opposite of our constant term to both sides, it means we're adding 15 to both sides. Combine our like terms on each side. And finally, divide both sides by the coefficient. We find out that n equals 1.23. Here, our 10 times in the numerator simplifies out with our 10 times in the denominator. Same thing over here. If we simplify a 10 out, we are left with a 1.23. If we test this out, does this fit on the rectangle? The second side here, second part of the length, turns out to be 18.6, which means we are multiplying out 5 times 21.6, the total of the 3 part and the 18.6, for 108. Seems to fit.